All right, today we are going to talk about absolute value inequalities. This is a kind of direct extension of compound inequalities that we were talking about on the very last video. So if you haven't watched through that video or you're not super clear on that, make sure you go back and review that because it's going to make a big difference. So I can even back up here just a second. So this was the compound inequality video. And the main idea is we have two types of compound inequalities. We have and, which we can see these two are examples of and compound inequalities. They come together, they cross over each other, and they intersect, and we have one section in between that is going to be the solution set. We also have an or inequality, compound inequality situation, and we can scroll down a little bit here and we can see that instead of them coming together, it's very, I guess kind of connected to the word or there. Sorry, I kind of lost my words for a second. But they go apart from each other. So and they come together. There's one section in between that's the solution, or the solution is actually going in either directions. It's either going to meet one or the other inequality, not both. So this is a very quick review of that. And then we also have to make sure we're paying attention to what kind of dot we're going to have. Is it going to be a closed or open circle or dot or point, whatever you want to call it. So if I have less than or equal to or greater than or equal to, that's a closed circle, closed dot. If I have less than or greater than, it's an open dot. And literally what these tell me visually, very quickly, is whether or not it's included in the solution. So an open dot is not actually included. It is a starting or stopping point, but I can't actually use it as one of my solutions. A closed dot is also a starting or stopping point, but it is included in the solution. I can use that number as part of the solution. Okay, so let's go ahead and flip back over here and look at the absolute value inequalities. We also have the absolute value rules that we practiced quite a few videos ago. So again, if you need to review that, please go back just a few videos in the playlist here on YouTube and you can find that. But when we have absolute value, what it means is we're looking at a distance from a point, from kind of a midpoint. So we can go to the right, we can go to the left. Right is positive when I move on a number line, left is negative. So first of all, this should always be a positive or look like a positive when we start this. Oh, dang it, I grabbed the wrong pen and it's messing up again here. There we go. Flipped to the wrong screen there. So we want this to be a positive when we start off. It's not truly a positive. It looks like a positive, but what it is a distance. It just means 14 units. So it's going to be 14 units to the right, 14 units to the left, but it should appear to start positive. Okay, so that's our very first thing. We have two cases whenever we see absolute value. Okay, those two little lines let us know. So I'm going to have case number one, and that's my positive case. And then I'm also going to have case 2, which is my negative case. All right. So for case number 1, all I'm going to do is take that inequality and drop the absolute value signs. So that's exactly what I'm going to have there. So 4w minus 6 is greater than 14. And I'm going to solve this. And then I'm going to do the same thing for the negative. The only difference is now I'm going to look at going to the left. Because it's an inequality, there's one more rule we have to pay attention to. Since I'm changing the sign here, I'm going from positive to negative, I also have to flip this sign to less than. So the sign actually flips around. That's a little different than a regular compound inequality because it's absolute value and inequality. So just those quirkiness of the absolute value there that it kind of throws out. All right, so let's go back over here. So we're going to solve this one. We're going to go plus 6 on both sides because I want to get w by itself. So 4w is greater than 14 plus 6 is 20. And I'm going to divide by 4, divide by 4. So 4 divided by 4 cancels, and I get w is greater than 5. So this is greater than, it means it's going to be an open dot on 5, and it's going to be greater than this amount, so it's going to go to the right. And then we're going to do this second case here. So it's going to be plus 6, and really I'm going to have the exact same steps, right? So 4w is less than negative 14 plus 6 is going to be, let's see, 6, 7, 8, negative 8. The 6's cancel. I'm going to divide by 4 on both sides. So 4 divided by 4 cancels, and I get W is less than negative 2, because negative 8 divided by 4 is negative 2. Again, I'm going to have an open dot because it's just less than. So it's going to be negative 2, and then it's going to be less than this amount. So we just ended up with an OR statement because they're going away from each other. They're apart. There's this whole section that doesn't count. I wouldn't use that in the solution at all. And I'm only going to be able to find one that meets either the less than situation or the greater than situation. I can't find a solution that meets both because they never cross over. So this is an OR compound inequality. And it's actually always, if I start with a greater than or greater than or equal to, either way, I'm going to end up with an OR, because what greater than tells me is that it's always going to be greater than this distance away from a midpoint. So greater than lets me know that it's going to be farther away, or it's going to be an OR statement. Let's look at the second one here. I'm going to scooch this guy down. Okay, so we're going to do the exact same thing. We're going to have case 1, which is our positive, and then we're going to have case 2, which is our negative. So case 1 is always the positive. That's why that needs to look like a positive already, because literally I'm just rewriting it without the absolute value signs. So I'm just dropping those signs. So if that wasn't already positive, this wouldn't work. And the positive one has to be the first one. It's always the first one. And we're going to go negative 5. Remember, that means I have to take this greater than or equal to sign and flip it around. And since it's greater than, I already know I'm going to end up with an OR. Even though it's greater than or equal to, it's the same thing. It's going to go apart from each other. So I already kind of have an idea of what that's going to look like. So I'm going to add 10 to both sides here. Boom. 5W is greater than or equal to 15. And then I'm going to divide by 5 on both sides. 5 divided by 5 cancels. So W is greater than or equal to 3, because 15 divided by 5 is 3. So this is going to be a closed dot because it's equal to on 3. And it's going to be greater than that amount. And then let's do the less than. So I'm going to add 10 to both sides, just like I did on that first case. 5W. The only difference now is it's going to react differently on this side, because it was a positive 5 plus 10. Well, now it's a negative 5 plus 10. So I just am left with 5. Because negative 5 plus 10, well, I really subtract these, and 10 is the bigger number, or it has more of them. So the answer is going to be positive there. Divide by 5 on both sides. 5 divided by 5 cancels, and W is less than or equal to 1, because 5 divided by 5 is 1. So I know it canceled on this side, and I didn't put the 1. Remember, we don't have to have a 1 in front of a variable, but if it's all by itself on the other side of the equal sign or inequality sign, we do need to put the 1. All right, so we're going to do a closed dot on 1, and it's going to be less than that amount. All right, so we had 2 examples of OR statements. So if you have an absolute value that starts with less than or equal to, then you're going to have an AND statement, because it has to be less than that amount. That it kind of gives a maximum limit instead of a minimum limit. So that is our absolute value compound inequalities. I hope that helped, and I'll see you on the next video.